Explain Newton's second law when the object is moving upwards or down. So to explain this one, let me start with the upward movement. So it's an object in an inclined line. So we want to determine the forces that act here. Then we have a certain angle, and then we want to find the forces when the object is moving upwards and or when the object is moving upwards. So we have a normal force, which is equivalent to the perpendicular weight. So this angle is the same as this. A parallel weight. So there are things that they won't change on this object. A parallel weight, this one, will always going down because it's a weight, it's the gravitational action caused by the gravity. So this force will pull the object downwards unless there's a friction which prevent it from going down. So this force will always be here, and there's only two forces that will interchange. Those is the friction and the applied force. Those forces will change if the friction force act that direction. The what you call the applied force will oppose that friction. So the applied force always oppose the friction. So when the applied force go up, the friction goes down. So let's take for in case the object is moving up, and which one is leading? The highest force. The highest force is the one that is the applied force, the force that leads every force. So it's too tough for the friction force. So the friction force would always be less than the applied force. If the object is moving, but if it's stationary, I mean the friction force is leading. So on this kind of object, like let's say you apply a force, let's ignore the gravitational acceleration or what. If the applied force is acting upwards, the friction force will act downward. So that means if the object will be moving upwards if the applied force is greater than the friction. Like this. So now I'm trying to compare the friction force and the applied force so that we can able to identify which one is which when you want to find these forces. So if if now the force is going and the object is going downwards, the friction will oppose what the applied force. So this is down. This is friction. So the friction will oppose the motion, and you can take it like this. The friction will always oppose the motion. So to derive the equation, you must know that the friction force does not go along with the applied force. So now let's take it, it's moving upwards. Object is moving upwards. Then the friction force will act downwards. Now it's up. So now we are trying to derive the formula for, and then you have the friction force acting downwards, and also the parallel weight will always act downward because caused by the gravitational force. So we must know that the apply force and the friction force, they always oppose each other, and the gravitational force, the gravitational weight, which is the acts downwards. So I mean this apply force is greater than 2. These two, the apply force and plus the friction force. So you'll have something like this. The apply force, it will be equals to the parallel weight plus the frictional force. This is, let's check the other one. If the object is moving downwards, remember the weight, parallel weight, always act downwards. So you can put it here. And then the object there, say now it's moving downwards. That means the apply force is greater now in down direction. In the downwards direction, then the friction will oppose the applied force. It's upward now. So now F down is great. Or you can add it or you can subtract it. So we can just cut it from here. You can say equals to the friction force will subtract the parallel weight or the horizontal weight. So this is how you'll draw the equation. Thank you for watching. See you in the next video.